Hello everyone, my name is Mayank Kushwa and I'm from ABS Engineering College Ghaziabad. I welcome you all back into this video lecture series on refrigeration and air conditioning systems. In the last video lecture, which is lecture 1, we discussed about the various type of refrigeration systems that we generally use, that we have developed over centuries of research. And then we moved on to discuss about what is the unit of refrigeration system, which is ton of refrigeration system. Also, we discussed about what is coefficient of performance. How do we measure the performance characteristic of a refrigeration system? In this lecture, we shall be talking about the comparison among three different type of devices, which are thermodynamically similar to each other. The first one is heat engine, another one is refrigerator, and the third one is heat. So the first device that I'm going to talk about is heat engine. Heat engine, you can think of a device like internal combustion engine that we use in our automobile systems, right? So in school level thermodynamics also, I hope you must have studied about somewhat similar thing. And I am quite hopeful that you are quite familiar with this diagram as well. So what we have here is that we have a device, heat engine, machinery heat engine, something like an internal combustion engine, which is working on a cyclic process. This heat engine is being supplied heat, certain amount of heat, QH, from a higher temperature body, TH. As a result of which it produces certain amount of work, and it also rejects certain amount of heat, let us say QC, to a lower temperature, cooler temperature, right? So we can just say that where QH is heat supplied, this is work done, and QC is heat rejected to the environment by this heat engine, like our internal combustion engine. You see? So for such type of system, we can define the efficiency as the efficiency of such a system commonly represented by eta as, again, the same thing, desired output by required input. So in case of heat engine, our desired output is nothing but work, whereas the required input is heat supplied. So we can say this is our one of the most basic formula for heat engine. Also, from first law of thermodynamics, we can say that cyclic integral of heat interaction is equal to cyclic integral of work interaction. So we can say that heat supplied at higher temperature minus heat rejected at cooler temperature is equal to output. Or we can use this thing as, we might use this equation at different levels, right? So from here, we can calculate this efficiency of a heat engine in basic terminologies, in basic parameters, which is nothing but the work produced by an engine to the amount of heat it requires to produce that work. Right. Now let us move on to the next thing, which is refrigerator. Refrigerator, if we have to draw the diagram, a similar diagram, then it can be done as right. But here you would observe that the direction of heat travel or heat transfer is now opposite. What we do in our domestic refrigerator, you would see that we absorb heat at a lower temperature and reject it to a higher temperature, right? So you would observe that the temperature inside the refrigerator is much lower than the surrounding temperature where we reject heat. So it can be done if we supply work in. You see, if we do not supply work, then you will see the refrigerator is violation of second law of thermodynamics, which is Clausius statement, right? What we are doing in refrigerator is absorbing heat from a lower temperature body and rejecting heat to a higher temperature body, which is the violation of natural laws because we know that heat transfers only from a higher temperature body to lower temperature body. But essentially, we are moving against the natural law of heat transfer in our refrigeration system. But this is only possible because we have to supply work. We have to do external work on the system. Whereas in the previous case, work was done by the system. We were getting work. It was a work producing device. Heat engine is a work producing device. This is work producing device. Whereas a refrigerator is work consuming device. Why it is consuming device? Because it has to work against the natural laws of heat transfer. You see? So let us write down here. So QC is, so let us say this is QH, just like the previous case. This is heat absorbed or this is what we call refrigerating effect, the cooling effect. Or cooling effect. This is heat, sorry, heat rejected to the environment. And this is work supplied. Obviously, TH is greater than TC. So if we have to calculate the performance characteristics, so we can define COP of a refrigerator as, again, the basic definition is desired output by required input. So if I ask you, what is that thing, what you want from your refrigerator? What do you want from your refrigerator? Cooling, right? And what is cooling? The amount of heat absorbed. QC, refrigerating effect. Refrigerating effect is what we require from a refrigerator. So In a refrigerator, we can define COP as QC divided by W. This is, let us say, equation number 3, right? Similarly, now let us move on to heat pump. Heat pump is, you can say, thermodynamically similar to refrigerator system. So in this diagram of a heat pump, you would not see a single difference as compared to refrigerator. Because thermodynamically, a heat pump is similar to a refrigerator. The only difference is in the desired output. In refrigerator, we want cooling effect as our desired output. We want how much cooling is provided by the refrigeration system or an air conditioning system. But in case of a heat pump, this heating effect is what we are interested in. We want to know how much heating is produced by the system, right? So in case of heat pump, what we are interested in is heating effect rather than cooling effect. So COP of heat pump is QH divided by W. Right? So you can think of a heat pump as the reverse of refrigerator system. Just for the sake of imagination, if you take one assumption that you switch the positions of your domestic refrigerator, so domestic air conditioner, right? Suppose the inside portion of AC is placed outside and the outside portion is placed inside, and you switch on the AC, then what is going to happen? The heat which you were earlier removing to the surrounding, to the atmosphere, would now be rejected into the room. Yes. So what will happen? That same device which you used for cooling purpose of the room can now be used for heating purpose of the room. Yes or no? This is the basic fundamental of heat pump, right? So whenever you purchase an air conditioning system, you would notice that whether it can work as a heat pump or not. It is written on each and every AC. So before the next time you use your air conditioning system, make sure you study the manual carefully. Right. So if we carefully observe our equation number 1 to equation number 4, we can conclude two very important relationships among the COP and efficiency of heat engine. The first one is from equation number 1 and equation number 4, we can conclude that efficiency of heat engine is reciprocal of COP of heat pump. Similarly, from equation number 3 and equation number 4, we can conclude that COP of heat pump is 1 plus COP of refrigerator. Right? These are two very important relations which more often than not are used in numerical portions. Okay. So make sure you remember these formula. Now here it might be a little bit confusing at this stage to understand the difference between a heat pump and refrigerator because both of them look similar, right? So I want to discuss how can we differentiate between a refrigerator and a heat pump. So basically, these can be differentiated on the basis of two, three parameters. First one is desired output. So from a refrigerator, we want cooling effect. From a heat pump, we require heating effect, right? Also, we can differentiate between these two things on the basis of their temperature range, in which these devices work. So, like refrigerator, if you observe the working of your domestic refrigerator, you would notice that your refrigerator is working between atmospheric temperature and a temperature which is less than atmospheric temperature. You see, the temperature inside the fridge cabinet is much lower than the atmospheric temperature. Whereas the temperature, higher temperature at which you are rejecting heat, your refrigerator is rejecting heat, is the atmospheric temperature. Whereas for a heat pump, these temperatures are the lower temperature is atmospheric temperature, whereas the higher temperature is above the atmospheric conditions, right? Which is quite obvious. If you are heating the room, then the inside temperature would be higher than the surrounding temperature. Yes, which is quite obvious. Similarly, COP can also be another parameter on the basis of which we can differentiate between the two, right? Hope you would remember these topics. Okay, that's all in this lecture. In the next lecture, we shall be talking about the FACOP of a system which is working on reverse Carnot cycle. Okay, some of the references which I've been following for this topic. Thank you.